Now in this slide you can see that the diagram on the left hand side is actually TCP header and the diagram on the right hand side is a UDP header. Now in the TCP header you can see source port number and destination port number. Similarly, in the UDP header you have source port number and destination port number. The rest of the fields in the TCP header is used for congestion control or detection of corrupted packets or malformed packets and all that stuff. So I will not going to discuss any other fields in the TCP header except the source port number and destination port number. So how does the TCP header or UDP header uses the source port number and destination port number? So both header contains two fields, the source port number and destination port number. These ports numbers are used by TCP/UDP protocol to carry out communication between two end processes. That is the process which are running on the source machine and the process which is running on the destination machine. Of course, we shall limit our discussion to port numbers only or fields in the other fields in the headers, especially the TCP protocol, are used for congestion control and error control and should be self-studied from textbooks. Again, as I said, the internal functionality of the TCP protocol is actually not that important because TCP protocol is actually a very standardized protocol. Once it has been implemented, it hardly improves over a period of time. It is a very much standardized and it is already implemented in most operating systems. And companies or MNCs actually hardly modify the standard TCP/IP protocol, they just uses it. So internal functionality of the TCP protocol is actually more for our researchers than is actually a piece of cake for researchers than actually it's a piece of cake for MNCs. So that is the reason that anything that is standardized and it's robustly implemented and is very much matured, the MNCs actually do not take much interest in discussing those things. So that is the reason that TCP protocol is actually not favorable from interview point of view, the internal functionality of TCP protocol. But yeah, you should know the what is TCP protocol and what are at a very high level you should know that what are the functions and operations of the TCP protocol and how does it differ from the UDP protocol, and you should know the use case. So that is the reason that this course do not cover anything which is of less important from interview perspective. So anyways, going forward, now we should discuss the header stacking. What actually is header stacking? So header stacking, you have already seen the header stacking in this course, but maybe you are not familiar with the technical term of it. So a header is a small chunk of leading message. So header is nothing but it is a message, but it is a leading message appended in the front of a message which contains the meta information about payload data it carries. Without headers, the payload data is unreadable or junk, right? So you have already studied that when you receive a packet, the first header in the packet is the Ethernet header, and the next header in the packet is some X header. Now, how will you know whether this X header is actually IP header, or this X header is actually ARP header, or this X header is actually IPv6 header? How do you know? You know this because the Ethernet header contains a field called type field, and this type field contains a number which is actually standardized and say that what is the type of header following after the Ethernet header. Similarly, if the next header is the IP header, the IP header also contains a special field called protocol field. This protocol field contains a standardized number which says that after the IP header, what is the next type of header. So like this, every header has to contain some information which conveys that what is the type of header or what is the type of message following that header. So this is actually called header stacking. That is one header following after the another header and following after the another header and so on. So how would you know that network layer header which follows the Ethernet header is actually IP header or IPv6 header or any other network layer protocol? Network layer header is payload to Ethernet header. Yeah. How would you know that protocol used in the transport layer is UDP or TCP protocol? So when the packet is received on the receiving machine, the network layer of the receiving machine has to hand over the packet to the transport layer. How will the transport layer will find out that the application is using UDP protocol or TCP protocol? Thus, header H always encodes some information which tells what lies ahead. Right? So it's basically that if I give you 10100100001 and I tell you that what I have written, it can represent a name, it can represent some age, let's say age, or it could represent anything. Unless I told you how to read these bits of message, it is a junk to you. Unless I tell you how to typecast this message. In C, how to typecast this message, you will not be able to read these bits and bytes. So it will be a junk to you. That is the reason that every header has to encode some information which tells the receiving machine that how to read the next set of bits and bytes following this header. So let's see this header stacking in action. Suppose you have an Ethernet header in the packet. So Ethernet header, of course, it will have destination MAC, source MAC, and the rest of the packet is called a payload. As I said, that Ethernet header contains a special field called type field. The type field contains a number, which is a standardized number. This standardized number actually conveys that what type of message is there in the payload. Now, if this type value is 0800, it means that the payload is actually a IP header. So you will typecast the next set of bytes after the type field as IP header. Now you know that it is IP header. So I will read the next sequence of bytes in the IP header format. Similarly, IP header also contains a special field called protocol field, which contains a standardized number. This standardized number identifies that what is the protocol that is running in the transport layer. If this value is 6, then the transport layer protocol is TCP header. It's a TCP protocol. And if the protocol value is 17, then the transport layer protocol running is UDP protocol. And if it is some other value, say X, then it could be any user defined protocol in the transport layer. So this is header stacking. That is, Ethernet layer has to convey the information that what is the next header in the packet. The IP header has to convey the information that what is the next TCP, what is the next transport layer protocol that is running in the transport layer. And the transport layer again contains the information in the form of port number, which actually identifies the application which is interested in receiving the packet. So Ethernet layer has the type field, IP layer has the protocol field, TCP header or the transport header has the port number fields, which is destination port number, and finally your packet reaches to the application. Application can have its own application specific header which only application knows or which only application understands. So this is called header stacking.